So we're going to talk about JavaScript today. 10 insane tips that you can use today to use ECMAScript 6, 2015, 2016, 2017, 20 star. Number 8 will shock you. I'm Brian Genisio. I work for a company called Khan Academy. It's our mission to provide a free, world-class education to anyone, everywhere. And when I say free, I mean free. We don't ever upcharge you. We don't ever take a credit card, unless it's donations. But that's never required. It's a really great place to learn something. If you need to brush up on your math, come check us out. If you're looking for a job, it's one of the most empathetic, skillful, talented teams I've ever worked with. I'm humbled every day by the people I get to work with, and I just learn from the personalities as well as the technologies that we're using. Check it out. We're actually really small for the amount of impact that the team has. It's a good 10 million unique visitors a month. We're about 130 people in size. So it just feels good to be a part of something that has that much reach. So I don't actually have 10 things. There's actually 12 things. It's going to be a list of things, hopefully more than 12. Number 8 isn't terribly shocking. It was really just link bait. I just wanted to get you here. Hopefully it worked. If you want to follow along or see these, I'll have this at the end as well. briangenisio.com/effective ES6. Just because ES6 was the name of it when I started this. It's just changed a little over time because things change. So these tips, these ideas, these thoughts, they're not my own. I kind of went out to friends, Twitter, community, coworkers, things like that, and said, hey, what are the features of JavaScript today that you really like, and how are you using them? And gathered a big list and kind of put it all together in that way. And you may come up afterwards and say, why didn't you include feature XYZ? There's several features that I'm not talking about today. Weak map, weak set, proxies, things like that. And a lot of the answers is that they're just not accessible yet. It might be because browsers aren't supporting them yet, or they're not easily transpiled. They're there in the spec, but they're not necessarily things that we're using every single day, and so you're not seeing it in the wild. There are some things we're going to talk about that are kind of available, but not necessarily complete enough to consider something you'd want to use in prod. And ultimately, I'm just here to talk about my opinion. That's all I'm doing. You've given me this microphone and this podium to talk, and so I might as well come up here and give my opinions and talk about them in a strong way, but hold them weakly. Meaning, I will not fight about these things, because if you have an opinion that's different than mine, it's probably right. This breeds conversation. This breeds somewhere to start, and then from there, you kind of can make your own opinions and hold them strongly, and have strong opinions that you hold weakly. And so, in other words, I'm trying to be more authoritative in my voice and less authoritarian in my voice. And so we'll just get onto the list. The first one, and again, strong opinion. I think if you want to be using these features, you really, especially in the browser, you want to be transpiling. And transpile is just a funny word that is a shortening of transcompile, which is a shortening of a slightly longer worded thing that essentially says I'm going to take one type of source code and I can compile it into another sort of source code. And in this case, we're going to be taking modern JavaScript and compiling it off into a less modern form so it can run in other places. And some reasons to transpile is that all the features I'm going to talk about today are available via transpilation. They may not be available in your browser, but if you transpile, they are available to you. So it opens up the set of features that we're going to talk about today. If you're talking about Node.js, many of these don't need transpilation. They're there today. But the neat thing about transpilation is you can say, okay, I'm going to transpile, but as the browser set that I'm working in supports these features, I can take away transpilation for all of those features and run them natively until you get to a point where you say, oh, all my browser sets that we support all the language features that we have, and you can even get rid of transpilation entirely. It also allows you to start playing with new and experimental features. We'll talk about some of those today. And it's battle-tested, production-ready, and widely utilized. I've been at Khan Academy for almost 2 years. We've been transpiling the entire time, including features that aren't completely standardized yet, but they're solid enough to really use. And we've got plenty of bugs come in. We got, like I said, 10 million unique users a month, and I can't think of a time when transpilation was the cause of our bug. It's really solid these days. And the output today is really quite clean. I debug in the transpiled output. You don't have to, but I do for a couple different reasons that I don't need to get into. The output is clean enough that you can follow it even though you didn't write it in the original source. And then there is this concept of source maps that allows you to debug in the original source when you're in the browser. So some reasons not to transpile. If you're using Node.js, you probably don't need to because the latest version of Node.js supports pretty much all these features. Your browser supports everything that you want to use, all the features you want to use. You may not need to transpile. Some people think the language has been perfect since 1999 and that we don't need the features that came a couple years ago. Some people just don't like nice things. Don't you love being guilted into? Sorry. So Babel is the state of the art when it comes to transpilation these days. There are other perspectives on how to do it, but for the most part, most of the transpilation is happening these days using a tool called Babel, and it's just a JavaScript compiler. There's lots of ways to use Babel. You can just transpile the code from the command line and include the transpiled code if you wanted to. Or you could use a bundler, which is something that kind of takes up all your files and figures out how to make little bundles of larger files, and it will use the pipeline to run Babel, and so you write it in one form and it just gets served up in another form. It's also, like if you're just playing with it especially, you can transpile in browser. You can bring Babel.js into the browser, and then you can write code that will get transpiled in a script tag, and Babel will transpile it on the fly and execute it for you. And then when it comes to how you set it up, there's lots of different presets that you can use. The most popular these days is what they call the env preset, which says, you get to say, I'm going to use these browsers and these versions, and Babel, you figure out which features to transpile and which features not to transpile. But you could say, I want to transpile all features from 2015, 2016, or 2017. Or you can say, I'm using React, so just transpile all the things that would be useful for React. Or you can say, based on stages. The way that the proposals work, it starts at stage 0, which is the basic idea of what we might want to do extremely early, where stage 4 is it's been shipped. And you can say, I only want to, or it's going to be shipped. And you can say, I only want to transpile things that are in a certain level of maturity within the series of how this all works. Now, to get to stage 4, some of these features do take several years. And so you have to decide, how cutting edge do you want to be? And that's up to you and your team. But it opens the door for all these features. Many of them we're going to talk about today, but you can pick and choose feature by feature which ones you want as well. So lots of flexibility there. You also get to open up experimental features, and I put it in quotes because JSX, if you're in the React world at least, JSX isn't really experimental. It's just not part of the JavaScript ECMAScript standard, and so it's considered experimental. Flow is a way to do some static type checking, kind of like TypeScript, but it's an add-on to the language as opposed to a superset of the language. Decorators, we'll talk a little bit about that, and many others. So that's transpiling. So we're going to start just now talking about actual features of the language. And the first one we're going to talk about is arrow functions. And the basic behind an arrow function is it's really syntactical sugar, for the most part, to turn a function into something that can fit in smaller space. Some people call them lambdas or lambda notation, but the idea here is if you have a function that takes a, b, and c, and it's going to return a plus b plus c, you can just kind of declare, I'm going to take these parameters and I'm going to return this result. Lots of languages have this. And so I'm going to talk a little bit about some functional programming concepts, but before we do this, I don't want to assume that everybody knows what map, filter, and reduce is, but the map function is a function that takes a set of items and will map them to another one-to-one set. And so based on a function. And so here's an example where you may have corn, a cow, and a chicken, and you cook, and you get popcorn, a burger, and eggs. I guess you don't cook a chicken to get eggs, but you get the idea, right? So it's a map. It's a one-to-one mapping from one thing to another. It's going to be the same length array in both cases. Filter is pretty simple. It says I'm going to likely reduce the set based on a function. So I'm going to filter on whether this is vegetarian or not. And then reduce says I'm going to take all the things in a set and I'm going to reduce it down to a single value or entity. And so you can reduce your food that you've cooked using the eat function down to some poop. A lot of these things aren't my idea. This came from this individual on Twitter. And so here's an example of using arrow functions in that type of thing. Let's say I wanted to get just the sum of manager salaries, and I have a bunch of employees. I can filter on whether or not the employee is a manager. I can map then, basically say, given a manager, a set of managers, return a set of salaries. And then I can reduce those salaries down to a single sum, and I can get the value of all the manager salaries in the company. And just to compare, this is how you would do it with the function notation we already know. And this doesn't add functionality. What it does is it makes it more expressive. The top version, at least in my opinion, is much easier to read than the version below because there's all this extra noise of syntax that gets in your way. This isn't a new concept. I should say, by the way, that a lot of these features that are in JavaScript that I'm going to talk about, they're not groundbreaking. We've seen them before in all other languages. When we went from 1999 to 2015 without really a single version update in JavaScript, people basically said, we need to take this language from a juvenile to an adolescent language. And that's why we're getting lambdas in this, or that's why we got lambdas in this language. Now, there's one thing that makes these things different. So functions and arrow functions are not the same because of the way scope works. And if you've ever played with JavaScript, you've probably dealt with this is not always the this that you think the this is. Because the function that calls your function gets to define the scope. It gets to define what this is. In an arrow function, this is what's called lexically scoped, which means the this of the outside of the calling function is the this that you get on the inside. And in other words, by using arrow functions, you don't have to write self equals this again. I haven't written self equals this in 2 years because I use arrow functions when I want that type of thing to happen. And it turns out that it usually works really, really well syntactically and from a readability perspective. So that is a difference, and it does make them slightly different. And so here's an example in the wild of how arrow functions are used idiomatically. And this would be in React.js. They have these things called stateless functional components, which are really just take some properties and transform them to a component. And this is how you'd normally see them being written. You could write it with function notation, but if you look around the web for examples of it, this is what you usually see. A component is equal props goes to this markup with the interpolation of the properties that it comes from. All right, the next one is block scoping. So var is dead. Again, opinions, right? But there's this thing about var in JavaScript, and you may all know it, is that var is, any variables defined with var in JavaScript is function scoped, not block scoped. Which means if I write this, var x equals 1, and then I have a block, and I say var x equals 2, my brain reads that and says, okay, that var exists in the block of the if statement. But if I come back down to outside of that block, I've now actually modified the x that was above it. And this type of thing leads to subtle bugs all the time. All the time, as in 2 o'clock in the morning, because the server went down and you pushed something you didn't realize. So instead, they've introduced block scoping. And so instead of var, you just say let. It's the same thing, except now the let x equals 2 is scoped to the block, not to the function, and it reads much more like you would expect it to. And they've actually introduced 2 block scoping syntaxes. The other one is const. And const is not to be confused with immutable. It's basically saying the reference of friends, in this case, cannot be changed. But of course, I could do something like this at the bottom, friends.push. I can mutate that thing because the thing itself can change, but the reference itself cannot. The variable within this function is not actually variable. It is more of a placeholder than anything else. It's a way of saying, I'm going to take the result of this thing, I'm going to put it here, and it will always be that set of friends. That set of friends may change, but that set is the same. And so it's gotten many of the people in the industry to suggest that there are some rules that we can apply to this when we're writing our code. And this is something Khan Academy and myself adhere to, and that is use const pretty much always. Use let when that value needs to change. Never use var. It's dead. And so here's an example of a function that has const and var. And I can look at this function really quickly and say, okay, I know the variables that change, and I know the ones that are really just placeholders to make the code easier to read. I know that the index in this for loop is going to change, and I know that people will always be that set of people. But really, for loops are dead too, in favor of functional composition. So these days, you usually see something more like this, where you will say, for each. You're abstracting away the logic. And one of the biggest reasons to do that is because how often have you accidentally done less than or equal versus less than? Or if you are using var, you can accidentally overwrite other versions, like if you had I as an index or things like that. And so this kind of abstracts the looping. Instead of you saying how to loop, you say that you want to loop. And this is what you're going to do when you loop. Another quick thing is, like, this is just an opinion of mine. Avoid let without assignment, mostly because I think it reads funny. When I say let result what? I'd like to say let result, even if it's undefined, be explicit. Let result equals undefined. So I can look at it and say this is what the thing is to begin with. And so in this case, the result is changing. But honestly, you can get rid of let in that case as well with more terse and many ways more readable statement. Now, ternary expressions, some people don't think they're as readable, and that's their opinion. Okay, the next feature is destructuring. So the concept of destructuring is basically you are going to, it's a syntax to extract things from something else. That's really the simple way of saying what destructuring is. And so we used to write code like this. You know, we create these placeholders because we don't want to write this.props first 8 times. We may want to just write first. And so we would write code like this. And what destructuring does is it basically just allows you to have this syntax that says, I'm going to, the variable name in this case is going to be the same thing as the property and the props that come out. It's a much more concise and in many ways more readable because there's less characters all over the place, but not in an obscuring way. And you can do this with arrays too. So if I had a winners list that I knew had 2 things, first place and second place, I can destructure them out and I can get the variables as opposed to saying winner list 0 and winner list 1. A clever way to swap without introducing temporary variables. Let's say you have A and B. You can say you can destructure the value of A and B into B and A. And you've now swapped B and A. I don't know if you'd ever want to write code like this, but it's more meant to be illustrative in nature. And so React is my space. That's where I do a lot of my work. So you'll see a lot of examples in React and other places as well. But React uses this a lot because in a render function, you want to usually render properties to the markup that you're going to put out. And instead of inside of this block saying this.props.heading, this.props.body, this.props.footer, I can just do a quick destructuring and then use them individually without having 3 lines of kind of the same code over and over again, which does introduce copy and paste errors when you have to do something like that. It reduces redundancy. You can also do this destructuring right in the parameter list of your functions. And so Redux, which is a state management library, says you're going to take the initial state, you're going to take a set of properties, and then you're going to return an immutable next state. And so in this case, I could say that the type filter is action. I could say action.type and action.filter, or I can just say, these are the 2 things I care about in that object. I don't care about anything else. These are the things I care about, and I'm going to use them in this function this way. I also like to use it for correlated data. You know, when I wrote this example, I don't know what I was thinking because I don't know what it means for a team to have a start and an end. Maybe like when they formed and when they, I don't know. It doesn't much matter. But the point being is like a lot of times you'll call a function and you'll want to correlate 2 things that are meaningful together. And to do that before you'd have to create an object, which we do down here. We do create this object, but then you'd have to pull those properties out in some way. And now we can just kind of correlate those 2 things together and communicate to the person using this function that these 2 pieces of data are related. Okay, so the next one, which is kind of interesting, is array spread. And what array spread says is I've got an array. I'm going to spread the values of these arrays as parameters to a function. And so the top example is how you might have done that in the past. If you had a function that took 3 things, but you had an array that you wanted to apply those values to as parameters, you'd have to call function.apply with the arguments, which is not terribly readable. And there's this, there's always the question, how is call different than apply and everything like that. So now we have this syntax here called array spread that just says ... array, which says spread the values as parameters to the function or the thing that you're going to be applying it to. And it's really useful for array composition. It becomes very, very readable now to say that I am going to be wrapping the A array with a 1 and a 5. I'm going to spread the results of, or the values of A in between them. So here's an example. I'd say I want to concatenate A, B, and C, create a new array. That's a way to do it. I don't know about you. That to me feels really readable when I look at that. I get a really good understanding on what it's doing. And so another example is array.push. Like the syntax for push if you wanted to push arrays onto it, is that you have to put the values as parameters. And so you used to have to do this ugly syntax above where you'd say array prototype push apply the values. And now you can just say push the values as parameters onto that function, and becomes much more readable. It's also really useful for immutable operations. So a mutable operation is something that does not mutate the thing that you passed in and will result in a new item returning. Used very often in state management. And so here's just how you would do append and prepend of an array in an immutable way. Remove is kind of similar. You can basically slice and slice, so you're getting to a point where you're removing that one thing and you're just kind of bringing them back together. Insert is very similar. You're going to slice, add the item, slice. Replacing, kind of the same idea. And then there's this concept of rest parameters, which is basically where you would, it's not spreading an array, it's taking the rest of what's left. And so this allows me to have, if you look at the parameters in the function up there, this allows me to have a variable length parameters when the function gets called. And so here is an example of how you might use that. I can just kind of give a list of all of the friends that Zach Morris has. Who gets the reference? Saved by the Bell. But bonus, objects are going to be able to do this too. So it's not just arrays. This isn't ratified in the spec yet. Hopefully it's going to come in 2018. But it's solid enough. We've been using this for over a year, and it's really nice. So you can do the same thing. You can spread the properties of an object into another object. And so in this case, the second line there, I'm just making a copy of the thing that was before. It's not a deep copy, because we're just taking the properties that are in the thing and putting it next to it. So we call the shallow copy. But then you can also extend the item. So I can give myself dark brown hair, for example. It's, again, used for immutable operations. The line in the second line there is kind of how we used to do it. And the third line is how we do it today. And it's probably a much more honest representation of my hair situation. Okay, this one's kind of funny. This is just kind of explains a few things about how things are implemented. So I'm going to just create a copy of an array, and I'm going to spread the emoji. And so this family of 4 is actually made up of 4 different emoji symbols internally. It's like an array of other things. The same is, same is true of any of these compound emojis. And some of them actually then they use color swatches. So in the case of a black Santa, it's the orange Santa with the dark brown color swatch, and Caucasian Santa is the orange Santa with a peachy tone swatch. So I don't know. I thought that was really kind of fascinating. Gives you some insight on how things work internally. Okay, default parameters. So again, these features are like not groundbreaking, but they're here now, which is fantastic. I can set a default parameter on my functions now. And this is really nice because now, does anybody know what undefined plus undefined is? Anybody? Undefined plus undefined? It's not a number. Which is true, it's not a number, but it's not what you would expect. So being able to come in here and define some default parameters, at least I can say, yeah, probably what I should do, you could also do is, in this case, you could throw an exception and be like, oh, I expected some parameters here. You could do that too. But if you have a suitable default, use a suitable default. And so it allows you to just completely avoid undefined, because if before having this, you'd have to check and make sure that the user exists. And now I can say, okay, if no user exists, I can give it a suitable default user. And I can also use this with destructuring. This starts to get into the realm of probably a little too clever, but you can now say that, okay, if there's no user, I want to default to an empty object. And I want to then destructure the first and last parameter, but if those don't exist, I want those to have values as well. And so they can be mixed and matched to whatever length is usable and readable for you and your team. They can also be used, in my opinion, for documentation. You can say that first is a string, last is a string, and times is a number. You're not going to get any type checking here, but it's at least some communication to the person reading this function of what it's going to take and what it cares about. And so we can go back to the Redux reducers example here. So the idea behind this is that these are meant to be these stateless functions that return immutable data. And so what happens is the very first time a reducer gets called with the state for the thing it's managing, it's actually passed with a state of undefined and no action type. And so what happens then, it kind of goes through the switch statement and you return the default state. And you can do that because you set your state to what you want that to be as a default above. Okay. Next one, template strings. Use these all the time. Finally, we can interpolate variables in JavaScript. And all we have to do is use this backtick. So now there are three types of quotes. There's single tick and double quotes, which are essentially the same thing. And then there's backtick, which are template strings, which are different in that you can do string interpolation now instead of string concatenation, which is really, really great for just readability. But it's also really great because they're multi-line now. And these carriage returns will get processed in that string. And so if I wanted to create a template, especially back when I was doing Backbone code, if anybody's ever done Backbone, I'd find myself writing templates like this all the time. If I had to be more dynamic than what my template engine could support. And now, if I had something like that, I could just do multi-line here as well. There are lots of use cases for having multi-line template strings, which I'll show some examples again. But there's this extra thing that's kind of cool about them, and that's tagged template literals. And that is, the magic here that is most important is this is the tag right here. So you can tag your strings with something. And as long as that tag exists as a function with this prototype up here, that function will get called with the string, and the result of that function comes out. And this is really just meant to be illustrative in nature, but the idea here is that you're going to get the strings and you're going to get the values. And so when I say strings, you're going to get first colon space, an array, space second colon space. So you can get two strings, and then you're going to get two values. You can get A, B, C, and D, E, F, or whatever the result of this interpolated block is. This can be any code you want it to be. You could write your entire app inside of this if you wanted to, not that you should, but you could, and that's what shows up in the values. And so it's a really simple example to show that if I actually called this function, what I would get is I would get uppercase values for the values, but the strings that weren't brought in are left alone. And how is this used in the real world? Well, you don't need to return a string from a tagging function. In this case, GraphQL, where we're creating a query on data, what it actually returns is a parsed structure. So it parses it one time and then passes the parsed structure around to the processors that are going to use it. Another thing that's really nice about this is that my linter now can look for this tagged string, and I can lint my query against the schema on my back end because I've got a syntax now that has said this string is a little bit special. It's a GraphQL query string. I've tagged it as such. Relay.js, which is another GraphQL state management system, uses the same concept. They relay QL, and then you do the same thing, and they do it in just a different way. There's something in React called styled components, and so basically it allows you to use CSS to define components. And so I can say, here's a button with this CSS. Now I got that button with that CSS, and I can pass it around however I want. So lots of different ways that you can use it. It's being used in templating engines and all sorts of different ways. Iterators and generators. So most languages these days have the concept of an iterator. An iterator is nothing but an object that you can ask for the next item. So an array by itself is not an iterator because it doesn't conform to the specification of what in that language what an iterator might be. It's an object that I can call next on and get the value of. So so here's an example of like how I might make an iterator of an array, and then I can call next, and then in this case, in the last time done is true. In the previous versions or the previous lines, done is false. So the basic structure of an iterator is an object with a next function, and the next function returns a value and a done. The done is the one that's important because if done is true, then value doesn't need to exist. But this is what the basic structure of an iterator looks like. And so you might find yourself writing code like this. This is like the naive approach to how you might use an iterator to step over things. Now that code isn't terribly readable. There are better ways to do it, and that's why the language now has another form of a for loop. We have for loops, we have for in, now we have for of. And so for of is something that knows how to iterate over an iterator, much like most languages that have iterators can do. And then a generator is a function that generates an iterator. These were modeled very much after C#, IMMUTABLE. In fact, you'll see very similar syntax here, where you have a function that can yield results. And the big difference here, this is the important difference, is it's a function star. That is the communication that is a generator, not just a regular function. And now I can yield results. And this is kind of like, it breaks the flow. If I were to call this function by itself, I would actually get an iterator as a result, not 1, 2, or 3. And then if I called next, I'd get 1, 2, and 3. Another term for this in computer science is coroutines. But here's a quick example of how I might just yield unique IDs from an iterator. Now the thing is, you would never want to use this in a for of loop because it will never terminate. The moment you put this in a loop, it's going to go forever. So this is a case where you want to know how your iterators are working, which is the case with pretty much any language. Here's the same thing, factorial. I can go get the values of factorial. This is a stateful way of doing a factorial. The state of the next item is maintained, so it's not a recursive factorial. Now, one of the things that's a little bit wacky about this, and this is, again, an illustrative example, we'll get to the point after this, but iterators in JavaScript are two-way, which means I can pass a value to the next function. So what we're saying here is the first time I call next, I'm going to yield 1. The next time I call next with 100, that is going to be the result internally of the yield. So now first is 100. So the result of this next is going to be 100 times 2. And I get 200. And then the next call is going to be 200. 200 gets set to second. Now we get 3 times second, and we get 600, and then we're done. Now, I never write code like this. I'm just trying to kind of like explain how this might work. But there's a real practical use for it. And so here's a library called code.js, coroutine, that word I used earlier. And I've got a generator now in this function that wraps it. And now what happens here is fetch user returns a promise. And co knows, well, if you returned a promise, I'm going to wait for the result of that promise, and then I'm going to take that result, and I'm going to pass it into the function of next. Therefore, now I get user. And now I can write this code that is synchronous in nature, sorry, synchronous in as you read it, but asynchronous in nature. Instead of saying fetch user dot then user dot not change return user, et cetera, I can write this synchronous code. And so here's an example. This is in Redux. This is a plugin to Redux called Sagas that allows you to do asynchronous action creators. And again, we're going to call an API, and then we're going to get the user. This moment is asynchronous. It's going to stop execution of this function, and when it comes back, that function is going to return. And it's going to keep on doing its work. In a future version of JavaScript, we're going to get language support specifically for use cases like this. And it's called async await. Again, I told you like this feature is very much modeled after C#'s version, and they also have async await, and it's a very simple concept. And now the language will support this asynchronous code written in an asynchronous way. Okay, classes. So this is one, if you talk to people who have been doing for JavaScript for a long time, people are like, I don't want classes. JavaScript is a prototypical language, and classes don't match prototypical structure, whatever. You know, when I want classes, I want classes. That's what I want. I don't always want it, but sometimes I do want classes, because sometimes they're really, really useful. It's a very, very, classes are a not very featureful implementation compared to other languages. You don't have modifiers like private and public and things like that. You really just kind of get to create a class, and it is syntactical sugar around prototypical inheritance, which is not part of this talk. But you can now write classes like this, and you can extend your classes in a polymorphic way, the way you would do object-oriented programming. And honestly, the place you see this the most is in Vue components and Vue libraries. So React uses this. This is the idiomatic way that you'd use, you create components in React. If not, you know, I talked about functional stateless components, which is a different paradigm, but if you're going to create a stateful component, this is the way that you would do it with a class. Angular 2 does the exact same thing. You define this component, you decorate it with some data, and now you have a component that that it's pretty clear what it's going to do. MobX, that's another state management library in JavaScript that also uses classes. It's like, anybody ever used MVVM in the past? It's essentially MVVM, but without all the performance problems that you can get with MVVM. That's what MobX is. And it uses classes the same way. All of these things, you don't have to use classes, but it's the idiomatic way that you do so in these frameworks. Aurelia, the same thing, another Vue framework. Now, you may have seen some syntax in there you didn't fully recognize, and that's this concept of decorators. These are like aspect-oriented programming, or this is like metadata for the functions. And so if we come back up here and look, and we see this, @observable, this is a decorator to this field on this class that says that this is actually going to be observable. This is a thing that you will get notified when it changes. Angular does the same thing. It says this class is a component, because the class is behavior, right? The class isn't, you know, how you would register it in the DOM. It's, you know, you may have the behavior, and you may want to have a different selector or a different template or something like that. The template isn't, it's weird to put the template right in the class. It makes more sense in this case to say that the selector and the template are metadata to the class, and so you can decorate your classes with this extra information. And honestly, all it is in implementation, it's a function that returns, that will take the class as an object and return it as another thing, so you can do work on it. Okay, property shorthand. So here's just an example of some code that you would see very often in the wild. And there's just some redundancy in it. For example, I'm going to get the headers, and I'm going to return the headers, and the headers are going to be named headers. And I'm going to stringify an object that I want to put in the body that are the first and last names. So I'm going to create an object with first and last, right? But it's redundant. I don't want to type first colon first and last colon last and headers colon headers. And now I don't have to. If I create an object like I have here, and I have something without the colon value, it's going to just assume that the variable name that you've passed in is the name of the field in the object you're going to create. And this just kind of dries it up a bit, right? It makes it a little bit easier to read with less redundancy going forward. And there's more capabilities, these shorthands. So these are some examples of code that you would have written in the past. The top one there where you create an object that has a function on it. You would say function name of some sort. Then you'd have the function syntax. I'll actually do these kind of side by side so we can talk about it. In the new shorthand notation, you can just, almost like a class, you can just define the function with a parameter or with a parentheses and move on. The next one down here where we say thing field equals something, this is when you have variable name fields. Usually you have like thing.foo, thing.bar, but sometimes that foo and bar is a variable, and you can do that with JavaScript with thing and field, but when you create the object, you can't do that in the old version of JavaScript. In the new one, if you put brackets around it, you can now have a variable in the field name to define it. And then the last one is getters and setters. You can have property getters and setters, and this is the way you used to do it. You used to define a property with a get function, and now you can just say get function, and that's just nothing but a getter without a setter. Okay, promises. So a promise in JavaScript is an object that represents the state of an asynchronous action. It is an object that is going to tell you when something has completed or failed, or neither if it hasn't. That's all a promise really is. And we've been using promises for years and years and years, and they've put it in the specification now for JavaScript to say this is what we want promises to look like. And it's really just a more fluent interface for asynchronous programming. So a lot of times before, let's say jQuery code, you'd say do something, and you'd have a success function, and you'd have an error function. And you'd have to usually kind of work with the code a bit to make it look good because you're putting success and error kind of separately and things like that. In the promise world, we just say do something. When it's complete, process the result. But if it fails, handle the error. And so that's the syntax of promises. And so let's look at a real world example. And at first you look at it and say, okay, I'm going to wait 1 second to do something, wait 2 seconds, do something else. Well, it turns out that that's actually pretty common with animations. You want to do custom animations, you may want to do something like that. And so in the old world, you would do a set timeout. You're going to wait 1 second, you're going to do something, you're going to set another timeout for 2,000 milliseconds, and then you're going to do something else. I had to jump around a lot there to follow what's going on, and it's not immediately obvious. But what if I just wrapped set timeout in a promise? And now I have wait, which is now a promise-ified version of set timeout. Now I can do something that makes a lot of sense. Wait 1,000 milliseconds, then do something, then wait 2,000 milliseconds, then do something else. Again, it's a fluent representation of the same thing. And then if you had a wait, you could do a wait as well. And you can make that look more synchronous, even though it's asynchronous. So a place this is used in the wild very often is fetch. And so fetch is kind of the new way that we call the backend from the browser in JavaScript these days. And fetch is just a promise-based interface wrapper around XHR objects, the way we used to do things. We used to get all these abstractions, like jQuery had $.AJAX, for example. Now it's kind of built into the browser. You can, in any modern browser, you can pretty much expect fetch to exist. And this is how it works. I can say fetch a resource and then translate it as the type, in this case JSON, and then process the users, and if there's an error, display the error. Mocha. Mocha is a very popular testing framework that sometimes you want to test things that are asynchronous. In Mocha, if you return a promise, that is a communication to the testing framework that this thing's not done working. And so now the testing framework will wait or time out for this promise to finally resolve. And so this is just a way to do asynchronous testing in Mocha. There's a different way too. There's that I don't have up here. Sequelize, it's a library in Node.js that is just meant to be like almost like an ORM, object relational mapper for databases. It uses promises heavily. GraphQL, which is a querying language on the server, has the resolvers, and I can say whenever I ask for this random number, I can fetch the random data, and if that's a promise, it will wait and won't return data to the user until it's there. Okay, so my last one here could be its own talk all completely by itself. And so I'm really going to gloss over a lot of these ideas, but there's a lot more to look into when it comes to this, and that's modules, loaders, and bundlers. So let's talk about a syntax in JavaScript that is available now called import and export. Finally, in 2015, we were given the ability to include a JavaScript file from another file. And we wanted that for years and years and years, and so people created all sorts of abstractions to do that for us, and there was no standard, and so now we have a standard, the language is given to us, and that's fantastic. I can import a component, I can export a component, and that language feature, or that language lets me do that. But the problem with that, there's two problems in fact, one of them is not really on this slide. The first one is Node.js had a different way of loading modules using, forgetting the name of the standard. Who knows the standard, the require standard in Node.js? CommonJS, right? They have a standard called CommonJS that isn't compatible with import and export. And so they have to do some work to make sure that we can support it. So right now, Node.js doesn't support import and export. And neither does the browser. Because it turns out that file systems that are completely disconnected sitting on a server are a lot harder than file systems that are on your system here. So when I say import, what does that mean? What does it mean to load that file from the path that you're supposed to load it from? How do you do it? How do you handle timeouts? How do you handle failures? How do you know what code to execute and what code not to execute, things like that. And so there's no standard mechanism to load these files. The language said, here's how we're going to import and export, but the browser said, we don't know how to standardize that. And so they're working on it. There's a working group called WHAT, W-H-A-T, WHAT working group, that is working on that right now, and browsers are starting to implement something like that. But in the meantime, there are implementations for doing that that will allow you to just import files. But one of the problems you run into when you do that is now I've got all these tiny files, and every time I ask for one file, and it asks for 8 more files, and it asks for 8 more files, I'm making a lot of little requests, at least in HTTP 1.1. In 2.0, we can start batching things, but you still need a protocol for how you're going to do that. And that latency makes our websites slower. So instead, what we tend to do is we tend to bundle. We tend to say, here are a bunch of files, or maybe all the files in my application that are similar to each other. And we're going to bundle them as one package and send that whole thing down. And then we're going to build a loader into that bundle, so you don't have to worry about what import and export means. I can call import and export in my JavaScript code, and you can be assured that it will load, even though the browser doesn't know how to do it, because the bundlers will handle that for you. And it'll also do transforms. We talked about using Babel before, minifying, uglifying, anything you might want to do. And you can get one large JavaScript file or lots of medium-sized JavaScript files or whatever you want. There's lots of different configurations. There's lots of options out there for doing that today. So that's a general overview of how we're doing things, in the JavaScript space today. There's lots of ways to JavaScript. There's lots of opinions out there still on how to do it, but those are some that have been codified in frameworks and things like that. We as a team at Khan Academy have found that standardizing on these new features allows us to write more concise and readable code. We use a tool called Prettier to make sure that all of our code looks exactly the same. Write it however you want. It's going to conform to the coding standard no matter what. And we use these bits in there to make it happen. So I have 5 minutes to take questions. I'm happy to chat in the hallway afterwards as well.